Good afternoon, everyone. Today I'll be recording a video on polynomials, and this is tailored to CAPE Unit 1. So let's just start really fast. Let's say we have 3x squared, or 3x cubed, sorry, minus 2x squared plus x minus 4. The first thing you need to know in polynomials is what the degree is. The degree or order. It's called either. So basically the degree or order of a polynomial is its higher power of x in the polynomial. So whichever value of x has the highest power, that's the degree of polynomial we'll say it has. So, for example, in this situation, this is a 3 right here, so this is 3x cubed. We'll say that this polynomial is of degree 3 because the highest power of x in this polynomial is 3. Next, let's say we have a polynomial f of x is equal to, I guess we could say something like, we could go with the exact same thing. 3x cubed minus 2x squared plus x minus 4. This is the next part of polynomials now. We will have evaluating polynomials. This will be, if let's say for example we would like to find f of 2. Whatever value of x we have, well, 2 is the new value of x, but wherever we see x, we'll replace it with 2, because this expression here was f of x, and we're trying to find f of 2. So simply wherever we see x, we'll replace it with 2. So 3 times 2 cubed minus 2 times 2 squared plus 2 minus 4. This is equal, so 2 cubed is 2 times 2, which is 4, times 2, which is 8, and 3 times 8 is 24, but we'll just leave it this way for the sake of simplicity. Minus 2 times 2 plus 2 times 2 is 4, so it's minus 2 times 4 plus 2 minus 4. So continuing this, we'll have 3 8s is 24, minus 2 4s is 8, plus 2 minus 4. And after this is just simple addition. 24 minus 8 is 16, 16 plus 2 is 18, 18 minus 4 is 14. Therefore, f of 2 is equal to 14. Something you should know from now though, if it is that the value of something when substituted is not equal to 0, then it's not a factor. It will not be a factor of that polynomial. But that's not something you have to concern yourself with yet. When we get to factor theorem, that will make more sense and I'll explain it more in detail. But just for you to start preparing, I would just like you to know that if it is that the value that's substituted in the x value will make the polynomial equal to 0, then it is a factor. Alright, next we're going to go to rational expressions. So let's say we have x minus 4 over x plus 2 is equal to 0. How could we find the value of x here? Well, what we could do is multiply both sides by x plus 2. That way we'll have x minus 4 is equal to 0 times anything is 0, so x minus 4 is equal to 0. Right? That will suggest, this implies that x is equal to 4. Right? Now we'll go on to a more complicated example using rational expressions, but it's still not complicated, like very complicated at all. It's still relatively simple as long as you understand the principle. So let's say we have x plus 1 over 2x minus 1 plus 3x plus 2 over x minus 3. Now, at the end of the day, these two things are still fractions. And to add fractions, we find the LCM. But what is the LCM of two things that don't have anything in common? Right? When we have a situation like this, what happens is that we'll use both denominators because these denominators won't ever be the same It's not, because they're variables, they're not constants. For example, if we had 3 and 6, we know the LCM would be 6, but these we have no idea. So we'll use both. So we'll use both denominators here. So we'll have the x plus 1, and what's going to happen is that we are going to add it to whatever value. So 2x plus 1 into 2x minus 1, sorry. This denominator goes into 2x minus 1 one time. So that's completely fine. But now we're left with the x minus 3 here. So we'll have x plus 1 times x minus 3. And I will add that to x minus 3 here. How many times is that going to x minus 3? Again, it goes in one time, which means that we'll have 3x plus 2 times 2x minus 1. Right? I hope you're following so far. All I did was just normal fraction addition. Very, very simple fractions, and I hope that's not too hard. Next, we're going to expand the brackets. By expand the brackets, I mean I'm going to multiply what's in these brackets so what's in the next. This will leave us with x squared minus 3x plus x minus 3. Right? And this is just on the left-hand side. We'll work on the right-hand side after. But let's just tidy this section up. So that will give us x squared minus 2x minus 3 plus, and it will work out this side now. 3x times 2x is equal to 6x squared. 3 times 2 is 6, and x times x is x squared. 3x times minus 1 is minus 3x. 2 times 2x is plus 4x minus 2. Next, what we're going to do is we're going to group all the like terms. So we'll have x squared plus 6x squared minus 2x minus 3x. Wait. Yeah, minus 3x plus 4x minus 3 minus 2. This will be equal to 7x squared minus 2 minus 3 is equal to minus 5 plus 4x is equal to minus 1x, which is the same thing as saying minus x. And then minus 3 minus 2 is minus 5. And all of this will still be over the same first two denominators, which are 2x minus 1 and x minus 3. Alright, I hope you're understanding so far. Next, we're going to be moving on to something slightly different. We're going to be doing it's called comparing polynomials, right? Or polynomial equivalence, whatever you'd like to call it. I'm not sure what they call it for everyone. But let's say we have x squared plus 4x plus 2 is equivalent to x squared plus ax plus 2. What would be the value of a? Now what you need to know is that since both polynomials, both of these, are equivalent, the coefficients must be the same. If that's the case, the coefficient for this is 1, the coefficient for this must be 1 as well, and that is true. 2 and 2, that's perfectly fine, which means that the coefficient for this x must be equal to a. Therefore, a is equal to 4. Now that's a very simple example. Let's go into a more complicated example. Let's say we have x cubed plus ax squared plus x plus 6 is equal to x plus 1, x minus 2, bx plus c. Oops. Bx plus c. Alright. So first, what you should always do, right? Sorry. What you should always do is expand. So we'll take the right hand side. Oh my, I'm so sorry. We'll take the right hand side here and we'll expand it by just multiplying what's in the brackets by what's outside the brackets, which will leave us with x squared minus 2x plus x minus 2, which will equal to x squared minus x minus 2. And this still has to be multiplied by bx plus c. So that way we'll have it equal to x squared times bx is equal to bx cubed, x squared times c plus cx squared minus x times bx is equal to minus bx squared minus x times c is equal to minus cx. And then minus 2 times bx is equal to minus 2bx. And minus 2 times c is equal to minus 2c. So in order, this entire thing should be equal to bx cubed plus cx squared minus bx squared minus cx minus 2bx minus 2c. Now on the other side, if you remember, we had this up here. So x cubed plus ax cubed plus x plus 6. Let me write that back. X cubed plus ax squared plus ax plus 6. Now we're saying that these two polynomials, they have to be equivalent. Right? We're saying that they are going to be the same. So if it is that these two are equivalent, that means that their coefficients must match. So we look for the polynomial with the same degree, bx cubed and x cubed. Very, very easy. Since the coefficient for x is equal to 1, that means b must also be equal to 1. Right? Oh, I'm sorry. I had ax here, but that should just be x. Yeah. But you get the idea. So b is equal to 1. And now what we need to find out is the value of ax. But right now it's seeming relatively complicated, right? But here's the easy part. If these two are the same and there's a standalone value, that means that the value of d is going to be untampered with. You don't need to know anything else for it. This suggests that minus 2c is equal to 6, right? Which allows us to solve for c. Therefore, c is equal to minus 3. Now that we know c, it can help us to solve for a. So if we have cx squared minus bx squared, we can factor out x squared, and then c minus b should be equal to a. And we know that c is minus 3. So where we have c here, we can put minus 3, minus, and we know that b is 1, because we found that out first. So minus c minus 1 should be equal to a. Therefore, we know that a is equal to minus 4. I hope you understood that example. It was slightly more complicated, and so I can understand if it's just a little bit hard to chew. Not physically chew, but I hope you understand. Right? Okay. Let's continue. Now we're moving on to remainder theorem. I'm kind of trying to just breeze through these topics relatively fast. I hope you're still understanding, right? So hold on for 1 second. I'm just going to add some more space so that this way, right? Nice. This way space won't run out. So essentially, remainder theorem is used to long divide polynomials, right? So what this means, uh, my dearest apologies, I had a little bit of technical difficulties. So, remainder theorem, that's what we'll be doing right now. Let's say we have, we'll have an example here. Let's say we want to find the remainder when 3x cubed minus 2x squared plus 4x plus 1 is divided by x plus 1. Alright, so what we're going to do, we're going to have x plus 1, and we'll just do long division. But long division is just it's very easy with polynomials. It's a very easy concept to pick up. So what we want to do is we want to multiply this value of x here by something to get 3x cubed. So x times what? What multiplied by x will give us 3x cubed? Well, simple. It will be 3x squared. So x times 3x squared is equal to 3x cubed. And then we have 1 over here. We'll multiply it by the value that we had up here. So 1 times 3x squared is equal to 3x squared. Now, here's the thing with long division, especially right now, what we need to do after we've done this part right here is we want to change the signs. So whatever signs are in here, right, we want to change them. So now instead we're going to be subtracting everything. So 3x cubed minus 3x cubed is equal to 0. That cancels out. And 2x squared minus 3x squared is equal to minus 5x squared. Now x times what gives us minus 5? X squared. X times minus 5x. Because x times minus 5x gives us minus 5x squared. So we'll get minus 5x squared. And we'll bring this down, plus 4x. And then 1 over here, times the same minus 5x will give us minus 5x. But here's the thing, we can't forget that we changed the signs. So with changing the signs, this becomes positive and this becomes positive as well. So these cancel out and we'll have 9x. Then don't forget to bring back down the 1. So 9x plus 1. So x times what will give us 9x? X times 9. So we'll have 9x. And then 1 times 9 is 9. So we'll have plus 9. And remember, we changed the signs. So this is now negative 9x and negative 9. So these two cancel out. And 1 minus 9, because we'll have 1 minus 9, since the 9 sign has changed from positive to negative, 1 minus 9 is equal to negative 8. Therefore, the remainder is negative 8. Next, we can also write what the quotient is. The quotient is this value up here, right? So we can say the quotient is 3x squared minus 5x plus 9. That's right. And that's really remainder theorem. If you didn't understand that, I'd recommend that you rewatch that part of the video, probably a couple times, or watch another video and read your textbook or something, but it shouldn't be too much of a hard topic to get. right? So I'm going to continue by giving us a more harder example. So let's say we have 6x cubed minus 4x squared plus ax plus b. And let's say this leaves a remainder of 5 when it's divided by x minus 1. And let's say it leaves a remainder of 1 when divided by x plus 1. What we want to do, right, is find the values, sorry, of a and b. But actually, right, I kind of skipped something, right? This is not remainder theorem. This is long division, right? What remainder theorem states is that if you take what you're going to be dividing, right, dividing by, right, let's say in this case we're dividing by x plus 1, what we can do is we can equate this to 0. Therefore, we can find the value of x. So x is equal to -1, right? And what remainder theorem states is that if you plug x is equal to -1 into the original polynomial, we should get, theoretically, we should get the same exact answer. So we worked it out with long division, right? And we found out that the remainder is -8. So let's try with the remainder theorem now. So let x be equal to -1, right? We'll have 3 times -1 cubed minus 2 times -1 squared plus 4 times -1 plus 1. This is equal. Something you should know, whenever something is inside a bracket, and I mean this for just numbers that are going to be squared, either positive or negative, I don't mean like the difference of two squares or anything like that, right? When it's going to be cubed, for example, anything that has an odd power will be negative, and if it has an even power, it will be positive, right? So since the power right here is odd, we know that this is going to be -1. It's just a very quick way of working it out. So what we'll have here instead is -3, because 3 times -1 is -3, and we'll have -2 and 1. Since this is an even number, it will be positive, so we'll have -2 times 1, which is equal to -2. So 3 minus 2, and 4 times -1 is -4, plus 1. This is equal to -5 minus 4 plus 1, which is equal to -9 plus 1, which is equal to -8. Therefore, remainder theorem is true. But now we're going to go to a more of a harder example. Now that I've actually covered remainder theorem. Sorry for forgetting it earlier. It happens, right? So this polynomial leaves a remainder of 5 when divided by x minus 1. So by remainder theorem, if we set x minus 1 equal to 0, we can get the value for x being equal to 1. So that means that 6 times 1 cubed minus 4 times 1 squared plus 1 times a plus b, this should be equal to 5. Let's sort this out more. Since this is positive in the bracket, it doesn't matter. 6 times 1 is 6 minus 4 plus a plus b equals 5. Now let's kind of search it out in a better way so that we can have a plus b by itself. So we'll add 4 and we'll minus 6. So a plus b is equal to 9 minus 6 is equal to 3. Right? So this is the first equation. What's going to happen is that we're going to solve it using simultaneous equations. So this is equation 1. Next, it says it leaves a remainder of 1 when divided by x plus 1. So when divided by x plus 1, it leaves a remainder of 1. So we set x plus 1 equal to 0. Therefore, x is equal to minus 1. And now we'll substitute minus 1 in. So we'll have 6 times minus 1 cubed minus 4 minus 1 squared plus minus 1a plus b. Ooh, my apologies. This is equal to, since this is an odd power, when it's going to be negative, so we'll have minus 6, and then and since this is even, it's going to be positive, and a negative times positive is negative. So minus 6 minus 4 plus minus 1a, which is equal to minus a, plus b should be equal to 1. Again, let's try to get a and b by itself. Plus 4 plus 6 plus 10. So minus a plus b equals 11. And this is equation number 2. So now that we have two equations, we can use simultaneous equations, right? So we have a plus b equals 3, and we have minus a plus b equals 11. What this tells us is that if we add these two equations together, right, these two will cancel out, and we'll have 2b is equal to 14 over 2 over 2, b is equal to 7. Therefore, since b is equal to 7, if we have a plus 7, because this should be b, is equal to 3, a is equal to 7, a is equal to 3 minus 7, and a is equal to negative 4. So I hope this explanation helped, right? And next I'm going to go to more of the bigger topic of this whole section, right? Okay. So next we're going to factor theorem. Let me just clear out some space. Oh, so let me just highlight the values for a and b here. And I hope you saw how I was able to derive these values. Alright. So now, factor theorem. Let's start with this. Let's say we have x cubed plus 2x squared plus 2x plus 1. And we want to know whether x minus 1 is a factor. So let's say we want to find out whether x minus 1 is a factor. So when x minus 1 is equal to 0, x is equal to 1. Now, if you remember in the earlier stages, right, I said that if it is that when a value for x is substituted in the polynomial, it equates to 0, that is a factor. So let's say we substitute 1 here. We'll have 1 cubed plus 2 times 1 squared plus 2 times 1 plus 2, which is equal to 1 plus 2 plus 2 plus 2 equals to 7. And 7 is not equal to 0. Hence, this is not a factor. Right? We want something that will give us a factor. So let's try x plus 1 equals 0. We're saying that x plus 1 equals 0 will be a factor. So when x plus 1 is, if x plus 1 is equals 0 is a factor, x would be equal to minus 1. Right? So let's substitute minus 1 here. So we'll have minus 1 cubed plus 2 minus 1 squared plus 2 minus 1 plus 2. So because this is an odd power, I'm really stressing the odd power because it really saves time, like mental time doing it in your head. It really saves a couple like small seconds, but every second counts on the exam. So that doesn't matter. So minus 1 cubed is equal to minus 1, and 2 times 1, because this is an even power, it will be even, plus 2. 2 times minus 1 is minus 2, plus 2. Sorry. This should be 1. I wrote it wrong. This should be 1. Right? And this value then, if this is equal to 1, then this is equal to 6. But we still know that 6 is not equal to 0. So this value should be plus 1. My apologies for all the mistakes in this video. This shows that minus 1 plus 1 plus 2 minus 2, that's equal to 1 plus 1. Minus 1 plus 1 is 0, plus 2, which is 2, minus 2 is 0. So we're now saying that x plus 1 is a factor of the expression x cubed plus 2x squared plus 2x plus 1. Right? Great. So here's what we can do. Now that we know one factor, we can just test to see what the other factors are, and we do this by long division. So x times x cubed. Well, what times x gives you x cubed will have x squared. I'll solve this one a lot faster because in the interest of time, right? I have to just make sure I do this properly in my head. This will give us x squared. Right. So now we know that x plus 1 times x squared plus x plus 1. These are two factors. And what we can do, right, we can use the AC method. So the coefficient of A, where A is equal to 1, B equals 1, and C equals 1. Well, what two numbers will add to 1? But I think we'll just leave it here for now, for this section. X plus 1, and that you should factorize it, but in the interest of time, I just want to kind of go a little bit further. And that's assuming if it can't be factored, then it just can't be factored, okay? So, yeah, let's continue going. Let's see. Now we want to talk about Descartes' law. So we understand what a factor is. So a factor of a polynomial is any value of x that will equate that polynomial to 0. And one key thing you guys need to remember, or I guess you could say one key factor, haha, very funny, is if it is at x plus 1, or if it is at the value of x is equal to -1, -1 isn't the factor. The actual factor would be x plus 1, right? That's one thing that I hope people don't get mixed up on, because you will get the answer completely wrong if you don't understand that. So now let's factorize this. Let's say we have, well, no, let's not factorize it. I'll explain something. I'll explain the Descartes rule. Let's say we have 4x cubed plus 3x squared minus 2x plus 1. Now, the Descartes rule basically states that the amount of sign changes, right, for f of x will show the roots to the equation. So let's check the amount of times there's a sign change, not the roots, but the positive or negative roots. And I'll show you the version for the negative roots, which I believe is a better version, but I'll show you the positive one first. So we go from positive to positive, no change. Positive to negative, that's one change. And negative to positive, that's two changes, right? Which means that, and then now, because they're two changes, we'll subtract multiples of 2. So it either has two positive roots, or 2 minus 2, or 0. So this equation either has two positive roots or 0 positive roots. Now, an easier version of this, right, Oh, and by the way, the other multiples of 2 we can't use because we can't have a negative amount of roots. Roots can have negative values, yes, but we can't have a negative amount of something. That's like saying the amount of water in this container is minus 5 milliliters. We can't have negative amounts of water in this container unless, well, we could if it was a there was an original amount of water. No, but this is going too deep. It's not that deep. We can't have a negative amount of roots, right? So next, this is the easier version. So let's say f of negative x. This is the version to get the negative roots is equal to 4 times x minus x cubed plus 3 times minus x squared minus 2 times minus x plus 1, which is equal to minus 4x cubed minus 3x. Yeah, minus 3x. Wait. No, plus 3x, sorry. Plus 2x plus 1. So we'll check the amount of sign changes. So this is not a sign change. Well, this is a sign change, sorry. From negative to positive is a sign change. And then from positive to positive, no sign change. And then from positive to positive again, no sign change. So we know that there's one sign change, which means that there's one root that is negative. So we know that we have a negative root here. All right. And yeah. Now, this, you'll never really, for CAPE at least, I don't believe you'll ever be tested. They're not going to ask you, using the Descartes rule, please tell us how many negative roots there are in this equation. No, I don't think they'll ever ask us something like that. Instead, what you can do is you can use this as a way to verify an answer that you've derived for yourself, right? So I'm going to go into one last example. I think that's the last example. I think after this, the topic should be done. Oh no, the topic's actually not done. I forgot I have to do the x cubed thing. Yeah, so the topic's almost done, right? But let's just go with it. So let's see. I'm trying to find a good question that we could work. That's like really good. Okay, let's say we have this. X to the power of 4 plus x to the power of 3 minus x minus 1. So how can we find a factor of this just randomly? So really we just have to brute force it. What I recommend at the CAPE level at least is to just use 1, negative 1, 2, negative 2, 3, negative 3. Just use those numbers, and if it doesn't equate, either try 4, 5, 6 or check to see if the question is valid. Because, yeah. So let's say we want to substitute f of 1 in here. Remember from earlier, wherever we see x, we'll put 1. This will be equal to 1 plus 1 minus 1 minus 1. So it's equal to 2 minus 2, which is equal to 0. Therefore, f of 1 is a factor, but f of 1 itself isn't a factor. If x is equal to 1, that means that x minus 1 is a factor, right? So we know that x minus 1 is a factor. So let's try another one. If we brute force that, we should probably be able to get another one, right? Let's try negative 1. So we'll have f of negative 1. And that will be equal to, since this is a positive number, we'll have positive 1. Since this is an odd number, we'll have a negative minus 1. Negative times negative is positive because we'll have plus 1 minus 1. This is the same thing as saying 0. So we know, right, if x is equal to minus 1, therefore x plus 1 equals 0. So we know two factors right now. We know x minus 1 and we know x plus 1. Therefore, we can multiply these two factors. So we'll have x squared plus x minus 1. Same thing as saying x squared minus 1. And because we have these two factors, we can long divide, right? And we can get the other factors. So let's see, x with other factor, because it's a polynomial of degree 4. So we'll find other factors. Normally for a polynomial of degree 3, by the way, you will have 3 roots. So always keep that in mind. For a quadratic, you'll have 2 roots, and so on and so forth. So we'll have x squared minus 1. I will long divide into the original equation, which is x to the power of 4 plus x to the power of 3 minus x minus 1. I'm going to go through this long division a little bit faster now that we're kind of far down in the video. If you still don't understand how to long divide and this video is not helping you, please read your textbook, please watch another video, click off the video and watch something else if it's not helping. So this will equate to x squared, because 2 times 2 is 4, yeah, and then we'll have x cubed plus x squared minus x which is equal to x squared. So we'll say plus 1 I'll bring down to minus 1. Minus 1 times 1 is equal to minus 1 to plus 1. By the way, I'm kind of doing these questions for the first time as well, so please bear with me if I'm not on top of it, because I like to have authenticity where I do the questions so that I kind of cement the information in my brain as well, since I am a student. So now we know these are the factors, right? But we can actually write out all the factors like this. We have x plus 1, x minus 1, x squared plus x plus 1. Isn't that nice? And this will be your answer, right? I hope this is making sense to you so far. If not, please click off the video. I do not care about the views or the likes. If it is not helpful, it does not make sense to continue watching this video. And if you want, you can just keep rewatching it until it clicks somehow. So let's say we have x to the power of n minus y to the power of n. So you should know already the difference of two squares, but if you don't, I'll just recap it real quick. X squared minus y squared is equal to x minus y, x plus y, right? This is pretty obvious. You should know this part, right? Everyone should have learned this. And this is called the difference of two squares, right? But now let's say you have x cubed minus y cubed. Now you can't use the difference of two squares like this because it's not the same. So what we want to do is we want to find a factor. So what could we substitute into x? This value of x to equal to 0. But we can factor in y, because f of y would be equal to y cubed minus y cubed, and that's equal to 0, right? Does that make sense? Oh, sorry, why am I asking that as though you could hear me? So if y is a factor, if y makes it 0, then the real answer must be x minus y. X minus y must be a factor. So now we can use long division, good old-fashioned long division. X minus y, x cubed minus y cubed. Now, this is where a lot of people get kind of confused. they get confused in the long division part, and I'll try to go very, very slowly because this is sort of similar, sort of different really, but it's very easy. I'm going to show you two ways to do it. I'm going to show you this way and a different way, which is, to me at least, slightly harder. So x times x into x cubed goes x squared times, right? And then y, negative y times x squared is equal to negative x squared y. But remember, we changed the sign, so it'll be positive x squared y. So then we'd have x squared y minus y cubed. X into x squared goes, x into x squared y goes xy. So that will give us x squared y minus xy squared, which is equal to plus xy squared. Give us xy squared minus y cubed, which is equal to plus y squared, which gives us x y squared minus y times y squared is positive y cubed. That's not, it's not minus y times y squared isn't positive y cubed, but this is what it will be because we're changing the signs. 0, boom, boom. Isn't this nice? This is very easy. See what I mean? Very, very easy. So we'll have x minus y, x squared plus xy plus y squared. And these are the factors of x minus x cubed minus y cubed, right? I actually won't teach the other way because I'm a little afraid that I might mess it up. And I know this way so well, and I actually have a pure math test like tomorrow, and it's on this topic. So I think for this video, I'm going to leave just that alone because I don't really want the issues. Now, let's say we wanted x cubed plus y cubed. Now, we can't use the difference of two squares when something's being added, right? Now, if this is the case, right, for x minus y cubed, what could we do to make this y cubed become a positive y cubed? Well, we could substitute we could substitute f of negative y. Well, no, we can't substitute f for negative y because that will equate x to negative y. What we can do instead is let y be equivalent to negative y. So if we say y is equal to negative y, then what will happen is this value what we have here, right? We'll have x minus y times x squared plus x minus y plus minus y squared. This is equal to x plus y x squared, and x times minus y is minus xy, and that's plus y squared, right? So that's really the only difference. It's just the sign of this thing right here, right? So I hope this is making sense to you right now. And let's say we have, so I'm going to continue now because that part was pretty simple, very easy concept to grasp. Let's say we have 8m cubed minus 27. Now what we want to do, right? We want to find a way to have both things cubed. So 8m cubed is the same thing as saying 2 cubed times m cubed minus 3 cubed, because 3 times 3 is 9 and 9 times 3 is 27. So what we can have next, we can just call this, we can say that 8m cubed on a whole is the same thing as saying 2m cubed minus 3 cubed, right? And this is where this is where we can, with x being equal to 2m and y being equal to 3, we can just use this same exact method we had up here. We can just substitute the values in here. And if we substitute the values, I'll just write it back right here so that we can kind of see for the negative one. X cubed minus y cubed. So we can substitute the values for x and y in here. So we'll have 2m cubed minus 3, that's such a weird 3 cubed, times 2m squared plus 6m. Wait, can we just multiply them? Yeah, I think we can. 6m plus 3 squared. Right, I think I have it now. This is equal to 2m minus 3. Oh, I'm sorry, by the way. These should not have values right here. We just pretend this never happened. We'll have 2m minus 3, and then we'll have 2m squared is equal to 4m squared plus 6m plus 9. Right, I think I got the concept myself right here. Like, I think it just kind of clicked for me as well. So I hope it clicked for you as well. But yeah. But let's say, for example, we wanted to factorize something a little bit more annoying, you could say. Okay, now before we get to that, right, I just want you to understand the difference of two squares properly. This is the same thing as saying x to the 4 minus 2 to the 4. Now, what you need to understand is that you can only use difference of two squares when there's a negative sign, like a x minus. Like, you cannot use it for positive, right? If you try it with positive, it will not work. Please do not do that. This will be equal to x squared plus y plus 2 squared, and then x squared minus y, sorry, minus 2 squared, which now, because we have a negative in this bracket, we'll have x squared plus 2 squared times x plus y, x minus y, because we can use the difference of two squares here, right? So we'll have x squared plus 4, x plus y, x minus y. Okay, I hope that makes sense. But let's say, for example, we wanted to factorize something like x to the power 5 minus y to the power 5. How could we do this? Now, again, we're going to find a factor. So we'll say that let f of y be equal to 0, because when x is equal to y, it will be equal to 0. Then we'll say that x minus y is a factor. So we will have, I'll write this one neatly because this is going to be a big one. X minus y and then we have x to the power of 5, and I will show you this. This is actually Pascal's triangle, so we're just going to work with this one for a second. I'm going to try to see if I can figure out this version. Plus 0 x for y plus, actually no, I have a test tomorrow. I'm going to just do it anyway. And then you long divide it by x to the power 5 minus y to the power 5. Right, so x into x5, x4. should be x squared y squared. Oh, sorry, I wrote it the wrong place. Plus x, y, 3. Ow, sorry. Okay, that was kind of a long working out. Yeah, so in short, the answer should be equal to x4 plus x cubed y plus x squared y squared plus xy cubed plus y4. Oh, that was a very nice working out. I totally have the concept now. I am sorry if you didn't get the concept from that. If you didn't, please check some other videos. Don't give up. Check your textbook. The textbook's always right. If you're using the Pure Math textbook, I'd recommend the big Pure Math textbook. I think it's like 500 pages. The one that everyone uses these days. If you check that textbook, everything should help. And yeah, I wish you good luck in your studies. I hope this video was somewhat helpful. It was very helpful to me to just kind of reiterate all the topics that we've been learning. So I hope it worked for you. Thank you, and I hope you enjoy your day.